Howdy and good day, fellers. It is a Tuesday, essentially a Friday for the week. We have a nice long break ahead of us. And welcome to your last Schultz remote video for hopefully a while, as I do plan on being back on Monday. So looking at our quiz from CO23, converting from standard form to slope-intercept form. They went okay. The average between all three classes was something around 65%. There wasn't one class that did significantly better than the other. And really, it came down to the second two questions on the quiz, where you had a negative coefficient to y, 5x minus 2y equals 8, and 6x minus 3y equals negative 24. In every single class, those two questions of those four where you had to convert, those first four were the lowest scores. And then function notation down at the bottom, the two of those there, we're going to talk about that again today. And your homework is going to be a quiz that you may even be able to finish in class. And it's going to focus on negative coefficients to y, when you've got those in your equation, because we need to work on that, and then back to function notation again, especially since function notation is a PO. We want to pass it the first time when the test comes. If you're not feeling very quizzical and don't want to take the quiz today, then Khan Academy is due on Thursday. If you're going to be traveling over the weekend and don't want to think about it, you might want to get that done now. Otherwise, math packet number 4 is due next week. If you want to leave it on my desk for me to come pick up and correct over break, then I can. Otherwise, yeah. Next Thursday, the 3rd, is the due date for retakes. Many of you have been emailing me practice work. That's been working pretty well, I think, all things considering. Where I take a look at it, I'll email you the retakes, you take pictures of them, send them back. I've updated my grade book with all retakes done so far, except if they were sent to me today, which is yesterday for you now, but I'm working my way through them. And since I'll be coming back next Monday, if you want to leave your practice work on my desk, then I'll correct it over the weekend. Otherwise, continue to email me and I'll email you. And we will have a retake day in class next week as well. But anyway, on to this. Okay. So let's go over. We'll start with the first one, even though it went very, very well. Just remember our process here. And one of the questions in that last thing there, do you understand? Do you have any questions for me? Someone did say that not quite sure why we're doing this. What is the point? Okay, what is the point? Well, the point is to be able to get to a type of equation that we're comfortable with. And you might not be comfortable with it yet, but when we actually start to graph these on the coordinate plane, slope-intercept form, I think it's coming up in PO20 actually, but slope-intercept form is going to be like your BFF, okay, or BGF, your best graphing friend, all right? Because it's so easy to do because it's got the slope and the y-intercept clearly defined, okay, M and B. But sometimes you'll be given equations that aren't in slope-intercept form. So just like we convert from decimals to fractions, or from fractions to percentages, or any of those other conversion things that we do, standard form to scientific notation, this is another form of conversion, where we're putting a given equation into slope-intercept form. So that's why we're doing this. It's going to make the graphing a lot easier. And it also tells us information about the line, right? Where it crosses the y-axis and what the slope is. We can get sort of a picture of what that line is going to look like. But anyway, 6x plus 2y equals 12. Our first step is going to be subtracting 6 x's. We're going to move those x's over to the other side. And we use opposite operations to do that. And again, I'm going to really stress here, pay attention to that sign. I think that's what's throwing us off in the second two that we'll talk about here. But positive 2y, and then 12 minus 6x, you can't actually combine because that 12 is a constant and that negative 6x has a variable. So instead of writing it 12 minus 6x because we want it in slope-intercept form, we're going to put that x term first, negative 6x, followed by a positive 12, and it ends up looking like negative 6x plus 12. Okay. Now our second step is to divide by that coefficient to y, and I'm really digging this whole heart thing here that we talked about yesterday. But basically, make sure that you are dividing both terms on that right side by that coefficient, not just the x term, not just the constant, both of them. Okay, and that gets us to our solution. Negative 6 divided by 2 is a negative 3x, and then 12 divided by 2 is a positive 6. Y equals negative 3x plus 6. That was the fourth option here. Okay, and a lot of you like to say, well, how do I check this? Okay, if you can pick an ordered pair on this line, and what I mean by that is, you've made function tables before. You had to do that on your last test, actually. Pick a value for x. Let's say, well, you know how much I like 0, right? X is 0. So if x is 0, then we get y equals negative 3 times 0 plus 6, or, since that cancels out, because multiplied by 0 is going to be 0, we get y equals 6. Okay? So when x is 0, y is 6. Let's go up here. If we plug in 0 for x and solve for y, 6 times 0 cancels out. We're left with 2y equals 12. Well, what value for y makes that true? 2 times what is 12? 2 times 6, which is exactly the y value that we have here. So if you pick an ordered pair and plug it into slope-intercept form, and then plug that same ordered pair in for x and y in standard form, both equations are going to work out. Okay, and that's how you know that you are correct. If I had gotten an incorrect answer, and I had, say, done this one, y equals negative 3x plus 12, I plugged in 0 for x, I would get y equals 12, which is not what I get when I do it up here, right? Get y equals 6. So, nifty, if you want to use it, but that's a good way to check your answer. Okay, second one here. Here's where the wheels kind of started to fall off a little bit. So we've got 5x minus 2y equals 8, right? That negative coefficient to y, we have a negative 2. We're still going to start by moving our x term over, and we're going to do that by using opposite operations. So we're subtracting 5x from both sides, but that negative sign has got to follow with your 2. Okay, that subtraction sign is also a negative sign. And then 8 minus 5x, we're going to write that as negative 5x plus 8. Okay, put that x term first. And now what happens here, because the most common wrong answer that I got was the third option here. And what happens when we divide by that negative 2, this time I'll write it a little bit differently so you can see that we're dividing both terms by it. When we divide by that negative 2 to get y by itself, this division right here, a negative 5 divided by negative 2, ends up being positive, doesn't it? Negative divided by a negative is a positive. So we get positive 5 halves x, and then a positive 8 divided by negative 2 gives us a negative 4. So this is actually the correct answer here. Y equals positive 5. Oops, hold on. Never mind. Y equals positive 5 halves x minus 4. Okay, and it comes from the fact that our x term becomes negative when we move it to the other side, and then we're dividing by that negative coefficient, which makes our slope positive. And I really think it's that coefficient to y that's being missed there. So watch out for it. Third one, same kind of situation here. 6x minus 3y equals negative 24. Okay, we're starting by subtracting 6x from both sides. And it just so happened here that all of our x terms were positive. If you did have a negative x term, then instead of subtracting it, you would add it to both sides. It's just still that opposite operations piece. It just so happens that all of our coefficients to x so far have been positive, which is why we've subtracted them all. But anyway, subtract 6x, we get that negative 3y, and on the right side, negative 6x minus 24. Both of them have that negative sign, and so it's written as negative 6x minus 24. Not minus negative 24, right? Because that actually means addition. Negative 6x minus 24. Now, when we divide by negative 3, and we do our little heart here, because boy, how we love this stuff. I said that sarcastically, but I really do. On the left side, we get positive y. Negative 3's cancel out. On the right side, negative 6 divided by negative 3. Again, that negative divided by a negative is going to give us a positive slope, positive 2x. And then, again here, negative 24 divided by negative 3, negative divided by a negative is a positive 8. So y equals 2x plus 8, option number 1. Okay. All right, and then the question here, what is true about the graph of the line that passes through the following points? Select 3 options. Basically, you were deciding, which one in each pair here was correct, right? Does the line cross the axis at 5, or does it not cross the y-axis at 5? Well, the y-intercept, since I give you this point 0, 5, the y-intercept being 5, the line does cross the y. Actually, I should make this is a checkbox. I should make a big old check. Okay, it does cross the y-axis at 5. The next one, the line is sloping upward, the line is sloping downward. Well, when you were supposed to plot these points and then connect them on the coordinate plane on your page, and when you do that, you get a line that looks kind of like that. Okay, since we read a graph from left to right, this line would be sloping upward. And, someone might come at you and say, well, yeah, but if you go like this, now you're sloping downward. Well, that's reading the graph from right to left. Okay, you read a graph like you read a page on a book or page in a book, go from left to right, and it's sloping upward. So, cha-ching. And the last one, the slope of the line is 1 over 1 on your coordinate plane. You can either count the grid squares, up 1 over 1, up 1 over 1, up 1 over 1, or you could use our slope formula. I mentioned that yesterday too. x1, y1, x2, y2. We get 5 minus 3 over 0 minus negative 2, which gives us 2 over 2, which simplifies to be 1 over 1. Yep. The slope of the line is indeed 1 over 1. Okay. So those 3 options are what you need to have to get this right. And something like 80% of you got all 3 of them. So that's just awesome. That's just awesome. Function notation. Welcome back, old friend. Okay, I'm going to try and fit both of them on here if I can. I can delete that because I've got examples of each type here, right? Remember that with function notation, you're either getting the x variable or the y variable, and it depends on how it's worded. When it says in the function f of x equals 4x plus 10, which remember that f of x is just a fancy way to write y. So in the function y equals 4x plus 10, what is f of 14? When it asks you f of something, what it's saying is, what is the function when x is 14? Okay, you can kind of think about it as, here's f of x, and even though that equals y, what did we replace? And to get f of 14, we replaced x. I'm giving you x. Okay, so what you would do then is you would take that x, plug it in for x in the equation, and you get y equals 4 times 14 is 56, plus 10 is 66. Okay, and because x was 14 and y was 66, that is the ordered pair. That would be the solution. So if you notice here, basically, your 4 options, you got 66 if you plugged 14 in for the x variable, but then you had to go one step further and tell me which ordered pair, right? Which one of those, each of them containing a 14 and a 66, which one is the actual solution? Well, ordered pair is always being written in an XY form. That X value comes first because I gave you X. X is 14. You solve for Y. Y was 66. 14, 66. The other two options here were if you did it backwards, where if you plugged in 14 in for Y and solve for X, which is the wrong method to use here. So I didn't give you Y, right? But if you did this and you solved it, then you would have gotten 1 as a solution for Y here. And so if you got this question wrong, you should be able to go back and view it. If you got it wrong, if you answered this one, you did the right procedure, you just wrote your ordered pair the wrong way. You wrote it backwards. If you answered either of these two here, then you did the wrong thing. You plugged the 14 in for the wrong variable. Right? So those are things that could have happened to get the incorrect answers. And only about 60% of you, 55 to 60% of you, in all three classes got this question correct. So it's definitely something that we need to practice and need to work on. The second one here, in the function g of x equals negative 2x plus 6, find x when g of x equals negative 12. Remember, this f of x, the g of x, the h of x, whatever letters you want to use here, it's just a fancy way to write a y. So when we say in the function y equals negative 2x plus 6, find x when y equals negative 12. Okay? Literally replace g of x with the y variable, and you read it in the function y equals negative 2x plus 6, find x when y is negative 12. Okay, so you're going to plug in negative 12 for y, and you are going to find x. Okay, if I see you do this on a test, where you write that and just kind of help you see it, I will give you an attaboy, attagirl. You won't hear it, but it'll be yes, do it. Right? It'll help you if you're continually getting these wrong. It's going to help you kind of remember that process. Which variable am I being given? Anyway, two-step equation here to solve. Subtract 6 from both sides. We get negative 18 equals negative 2x. Divide by negative 2, and negative 18 divided by negative 2 is a positive 9. So x is 9 when y is negative 12. X is 9 when y is negative 12. That is this ordered pair here, which is the correct answer. Again, if you answered that one, you did the right thing. You plugged negative 12 in for the correct variable. You just wrote your ordered pair backwards when it came down to putting it in the ordered pair. If you got either of these answers, then you plugged negative 12 in for x, and you found y. You did the wrong procedure. You plugged it in for the wrong variable. So before you take this quiz, I recommend going back and checking. Okay, you can't edit anything, but you can look at it and see if you got it wrong, which thing you did. So you know not to do that thing when you take your quiz today. Okay. All right, that is enough of me. I am done. The quiz today will focus on those negative coefficients to y in going to slope-intercept form, and then function notation as well. Don't forget about Khan Academy. Do Thursday, math packet due next week, practice work and retakes. It's all kind of coming together, which is bound to happen at the end of a trimester. At least you don't have any math tests before the end of the try, so you don't have to worry about that. But anyway, have a tremendous Thanksgiving. I am very thankful to be here, very thankful to be meeting and getting to know all of you. Thankful I didn't drop my pen today. That's a first for this time I've been away. But I will be back Monday, and so this is the final time that I will say to an empty classroom, at least hopefully for a while, do not forget to like and subscribe.